so far, we've just done everything with one set of data, right? Even when we did the paired t-test, we were still subtracting, and it was really one set of numbers, right? So now we're going to compare two proportions, and then we're going to compare two means in this chapter. And we're going to do all the stuff that we did with everything else. So we're going to do confidence intervals and the significance tests. Yeah, all in one chapter. Yeah. So, but it's pretty much stuff you know, except now we're doing the difference between two of them, okay? So to explore the sampling distribution of p hat 1 minus p hat 2, okay, the p hats, by the way, are from the sample, right? That's what you get when you do a sample, not the true proportion, but the sample. Let's start with two populations having a known proportion of success. So typically we don't know the true proportion, all right? But we're going to start with knowing the true proportion. So suppose there are two large high schools, each with over 2,000 students in a certain town. At school 1, 70% of students did their homework last night, and only 50% of the students at school 2 did their homework last night. So that's the true proportion, so that's just P, and the true proportion for the other one, so P1 and P2, okay? The counselor at school 1 takes a simple random sample of 100 students and records the proportion that did their homework. And school 2's counselor takes a simple random sample of 200 students and records the proportion that did homework. What can we say about the difference in the sampling proportions? So P1 with a hat on it minus P2 with a hat on it, so the sampling subtracting, okay? We know the true proportions right here, all right? So just a little graph for you. If we were to do a dot plot, and we took a whole bunch of simple random samples. So P1, this is our proportion of students who did their homework. And in the first sample, how many did she take? I don't remember. 100. All right, so she was doing 100 students. So if she did that 1,000 times, right? So each one of these represents, out of 100 students, the proportion that did their homework, and then out of 100 students, so you got a whole bunch. And we end up getting, they should tell us in here. Let's see. Oh, 0.68, okay? For all 1,000 of those, we get 0.68. What do we know the true proportion to be? 0.7. So the true P1 for the first school is that 70% did their homework, right? But when we do the sampling distribution, it's not going to be perfect, but we took 1,000 simple random samples of 100 students each, and that's what we got. All right, P2 is school 2, and we got 0.505 from 1,000 of our simple random samples, and this time we had size 200. And it looks more like this. We had 0.505. What did we know the true proportion to be for school 2? Yeah, okay, 50%. Okay, oh wait, let me go back to the last graph. So this one is P1 minus P2. What would we expect P1 minus P2 to be, you guys, based on the truth? 0.2, okay? We know 70% did their homework and 50% did their homework. We would expect it to be 0.2. And on this one, our sampling distribution would be a little different. We would do this minus this, but it would be close to 0.2, all right? So back in chapter 7, back in the day, we learned these lovely facts. So we have to talk about shape, center, and spread, all right? This is just a review of what you already know. So how do we check to see the shape? Well, we check for normality by n times p greater than or equal to 10, and n times 1 minus p greater than or equal to 10, right? That's shape. Check for normality. The center. So the center is mu of p hat. So this means the mean of all my little p hats, right? If we know the true p, we should say it's the true p, all right? And then we have our standard deviation of all the little p hats. If we know the true p, we can use this formula, p times 1 minus p all over n. And for spread, you have to check the 10% condition. All right, everyone remember that? I hope hope so. So let's just do these real quick. Let's check the sampling distribution of just P1 hat. This will go quickly. How many people did we take in P1 hat? What was our sample size? 100. All right, and we know the true P. We know 70% did their homework last night. So we get 70. And we started with 100, and we have to also check 30%, and we get 30, and both are greater than or equal to 10. So we would say approximately normal. All right. And the second part for the center, because we haven't done this in a while, you have to write it like this. Mu of P hat, the mean of all my little P hats. If we know the truth, it's equal to that true P, which in this case is 70% that did their homework. And our standard deviation of all our little P hats is the square root of 70 times 30 divided by the 100 sample size that we took, and we get this lovely number. All right? So for the distribution of P2, what was our sample size? What was our N? This time it was 200, and we know the true proportion was 50%, and 200 times the other 50% is still 100. And so greater than or equal to 10, so yay, we're normal, okay? And then our center, again, if we know the true P, we should state it. And you guys, we just did the formula for spread. By the way, what do I have to check, though, for spread? The 10% condition, which I didn't do, so I probably should. 100 is less than 10% of all the students. So we assume there's at least 1,000 students in the school, which that's what it said, all right? What if we combine them? So here's the new part where you might want to write it down, okay? We took a little break because that was all kind of review. So we're checking the same things, shape, center, and spread. That's how you describe the sampling distribution. So for our shape, instead of just doing 2 things, we have 4 things. It's exactly what we already stated. N times P greater than or equal to 10 for every single one of them, right? So we got 70, we got 30, and we got 50, and we got 50. So that's greater than or equal to 10. So because all 4, right, both distributions, N times P is greater than 10, and N times 1 times P is greater than 10. We already did it, right? So yes, it is approximately normal. Okay. And then we have the center. So this time I'm taking the average of the differences. If we know the truth, we should use those. So we're just going to do 70 minus 50. And so the center is 0.2. And the spread is new. So back in the day, we talked about adding and subtracting. And we talked about that when you did variance, no matter what, you added. So even if you're subtracting, you are adding the 2. And there is an explanation in your book if you're curious, but I would probably just write down the formula for spread when you have 2 and you're subtracting. All right, these should have P hats on them. All right. So spread means standard deviation of P hat 1 minus P hat 2. This should be a 1 right here, sorry. So you do the P times 1 minus P over N, so that would be our first one, plus the second P times 1 minus P over N, and we square root the whole thing. Without the square root, it's variance. When you square root it, it's standard deviation. And again, you have to check the 10% condition for each separate sample, okay? And in case you didn't write the other stuff down, right, don't forget all that. All the same thing. Now, right now we know the truth, which makes it a little easier. We know our true P in this example. All right, so let's calculate our standard deviation. For our first one, what goes in for P? Okay, and that would mean 30. And what was our sample size? 100. For the second one, what goes in for P? Good. And then another 50. And this time our sample size was 200. All right, calculate that out. And you guys get 0.0971. Actually, no. Sorry, I'm looking at a different one. 0.579. Wow, I can't do this. 0.579. Okay. And check the 10% condition for both. 100, we have at least 1,000 students, and we have at least 2,000 students in the other building, so we're good to go on 10%. Okay. Okay. So let's do one example, and this is the last example here for the day. Thanks, guys. There's a short lesson for you. So describe the sampling distribution. So whenever it's sampling distribution, think of SOX. All right, that's what we're doing. SOX. You guys still remember that? Shape, outliers, center, spread. Okay. Your teacher brings 2 bags of colored goldfish crackers to class. Sorry, I didn't. Bag 1 has 25% red crackers, and bag 2 has 35% red crackers. So we know the true P. We know the true P right there, because they're telling us. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 crackers from bag 2. Let P hat 1 minus P hat 2 be the difference in the sample proportions of red crackers. What is the shape of the sampling distribution? All right, so let's check shape. So shape, you guys, is when you have to do check normality, N times P, right? So how many crackers in the first bag, or how many are we taking in our sample? Let's do bag 1 first. So we'll do 50. Okay, and we're going to multiply times the true P in bag 1. What's that? Okay, 0.25. That's 12.5. Then we got to do 50 times 0.75. And that's 37.5. All right, now we check the other bag. How many crackers? How many did we take? 40. And what's the proportion of red crackers in bag 2? Okay, 35%. So we get 14 for that. And 40 times 65%. And we get 26. So all of those are at least 10. So approximately normal. Jake. If they ask you to describe a sampling distribution. Why would we do the difference in proportions? Like you need a good example problem or something? I don't know. Like, let's look at another. This isn't good enough. You don't care about the crackers in the bag. They've got some good ones in here, actually. Yeah, like different drugs you want to compare, or something to a control group. You're comparing the difference or the increase.
Does polyester decay?
We definitely want to know that. Okay. B, find the mean. The mean part is super easy, especially when they give you this truth. But you have to be sure you write it like this. Okay. The mean of the subtraction of those. So we would take P1. Bag 1, our true proportion is 25%. Bag 2 is 35%. Okay, whatever order you subtract in, you should get the same answer. All right. So it's okay if you switch what you define your variables as. Okay, that's all you have to do for the mean of the sampling distribution. And then we've got the new formula you have to memorize, right, for standard deviation. So the spread or the standard deviation. I'm just going to go ahead and substitute in. What goes first for my P? 0.25. So then we have 0.75. And what was our sample size? 50. Okay, and my other bag, what's my P? Good, and then 0.65, and my sample size is 40. All right, then plug it into your calculator and you get 0.0971. So what does that number actually mean? And you might want to make note of this. Occasionally, it is asked in the homework what that that standard deviation means, and it's been a while kind of since we've talked about this. So in repeated samples like these, so your 40, groups of 40, groups of 50, the difference in the sample proportions of red crackers in these two bags will typically be 0.0971 from the true difference. So our typical distance away from the true mean, right? So we know the truth is negative 10% difference in proportions. It will typically be off by that much when we draw those samples.